Hello student, I am Tanmoy Majumder. Today I am going to discuss one of the most important topic, regression analysis. In previous video, I have discussed correlation coefficient, which is the degree of association between two variables or the relationship between two variables. Now you should know what is regression. Regression is used to denote estimate or predictions of the average value of one variable that is unknown for a specified value of other variable that is known. It means depending on one variable, we make predictions of other variables. So we can say simple linear regression is actually a basic regression analysis where we have just two variables, an independent and dependence. Based on the changes made to the independent variable, we predict the dependent variable. For example, the amount of crop yield based on the amount of rainfall received. Here, rainfall is independent variables and yielding crop is dependent variable. So here you should remember one thing. Correlation analysis attempts to study the relationship between the two variables x and y. But regression analysis attempts to predict the average x for a given y. So that estimations or prediction is done by means of a suitable equations derived on the basis of available bivariate data. Such an equation is known as a regression equations. So in the next slide, I am going to discuss the linear regression or simple regressions and the regression equation of x on y and y on x and the derivations of the regression equation. Now student, I am going to discuss some of the formula of regression equation and regression coefficient. Now in linear regressions or simple regression, the relationship between the variable is assumed to be linear. Now what is linear equation? Linear equation is an equation between two variables that gives a straight line when plotted a graph. So suppose y is equal to mx plus c. Anyway, we will discuss later in details what is linear equation. Now, as I have told, that regression analysis is used to estimate the value of dependent variable from the value of independent variable. So definitely we will get two variable y and y on x. Suppose in the first case, the regression equation of y on x means we are estimating the value of y for a given value of x. At that time, the formula I have written, that is y minus y bar equal to byx into x minus x bar. Here the byx is the regression coefficient of y on x. Okay. So you should remember one thing, when we are estimating y on x, means estimating the value of y on x, at that time the regression coefficient will be byx. Okay. Now the regression coefficient the regression equations of x on y, just reverse. X on y means we are estimating the value of x for a given y value. So at that time the regression equation will be x minus x bar equal to bxy into y minus y bar. Here the bxy is the regression coefficient of x on y. So definitely you should keep remember one thing, when we are estimating the value of x on y, at that time the regression coefficient is bxy. Okay, and when we are estimating the value of y for a given x value, at that time regression coefficient will become byx. Okay, keep remember these things. Okay, that is the difference. Okay, now come to the next formula that I have written, that byx, now regression coefficient, byx, regression coefficient of y on x. The formula I have written, that is ryx into sigma y divided by sigma x. So you know what is ryx, is the correlation coefficient between two variable x and y, and sigma y is equal to the standard deviation of y, and sigma x is equal to standard deviation of x. Now ryx, we just write down the formula of ryx that you know already, covariant of xy divided by sigma x into sigma y. Okay, and sigma y divided by sigma x, it will be remain same. Okay, now sigma y will be cancelled, we will get sigma x square. In the next line, in the denominator portion, we will get covariant of xy divided by sigma x square. In the denominator portion, it will be sigma x square. Okay, clear? Okay, now what is covariant of xy? In the box I have written the formula of covariant of xy, that is summation xy divided by n minus summation x by n into summation y by n. That is the formula of covariant of xy. Okay, and you know is already I have already explained the formula of sigma x. There is a standard deviation of x. The formula is root over summation x square divided by n minus summation x by n whole square, that I have written. Okay, now what is standard deviation of x whole square or sigma x square? Root will be cancelled, rest other portions will be remain same. Summation x square divided by n minus summation x by n whole square. Okay, clear? Now from here we can write that covariant of xy divided by sigma x square. We just put the value of covariant of xy. Covariant of xy is, I have written, is a formula, that is summation xy divided by n minus summation x by n into summation y by n. Okay, now sigma x square is a formula I have written. The sigma x square is summation x square divided by n minus summation x by n whole square. Now both the denominator and numerator, if we will dividing by n square, then definitely we will get the next step, means or next line, n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. Clear? So that term I have written here. Byx means the regression equations of y on x equal to n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. Similarly, we have written bxy, rxy, it means bxy equal to rxy into sigma x divided by sigma y. Okay, now rxy equal to covariant of xy divided by sigma x into sigma y, and sigma x and sigma y will be remain same. Okay, now sigma x and sigma x will be cancelled, and in the next steps we will get covariant of xy divided by sigma y square. Okay, now after deriving the same thing in similar process, we will get n into summation xy minus summation x into summation y divided by n into summation y square minus summation y whole square. Now you should keep remember some difference here, that when we have just calculated bxy, means regression coefficient of x and y, the denominator portion is n into summation y square minus summation y whole square. Okay, but when we are calculating the regression coefficient of y on x, at that time the denominator is just changing n into summation x square minus summation x whole square. So that is the difference between the regression equations of byx and regression equations of bxy. Okay, you should keep remember this difference. Okay, now if we will jot down the all formula, then definitely you should keep remember the whole formula in some of the formula, that is regression equations of y on x. We have written y minus y bar equal to byx into x minus x bar. The regression equations of x on y, x minus x bar equal to bxy into y minus y bar. Regression coefficient of y on x, ryx into sigma y divided by sigma x. That after deriving we got byx equal to n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. And the regression coefficient of x on y, rxy into sigma x divided by sigma y, and after deriving we have got bxy equal to n into summation xy minus summation x into summation y divided by n into summation y square minus summation y whole square. So that are the formula you should remember. So when we are solve any problem of the regression coefficient, we should apply this formula. Okay, for that we should remember this formula clearly.